Hello, everyone. Thanks for attending our webinar today on high throughput automated solid phase extraction and full scan GC triple quad for the analysis of wastewater using EPA 8270D. And so for the folks that are watching or participating internationally, basically semi-volatiles and wastewater. Talk a little bit about our company, Fluid Management Systems, and then Joel Farrar will speak about the Agilent product and application in the second half of this. Ruud will cover the technical portion for us here at FMS. So Fluid Management has been around since 1986. All we focus on is automated sample preparation and consumables for GC, GC mass spec, LC, and LC mass spec products and analysis. So we're based here in Billerica, Massachusetts, and all of our products are made here in the United States. So we have a machine shop, clean rooms, etc., for manufacturing our consumables as well as our products. We're going to talk about the two portions of the laboratory workflow, which are kind of the most time-consuming in the laboratory. So we have the extraction, cleanup, and concentration portions, which take up the bulk of the actual sample to analysis workflow, and then the analytical run, which will be handled by our good friends over at Agilent, and they'll speak about that. So we make a lot of, for those who are unfamiliar with fluid management systems, we make a variety of solid phase extraction systems. We have systems that are made for drinking water only, which is called the EconoTrace on the left. We have the TurboTrace, which is for drinking water and wastewater, which is your second from the left on the screen. And we have the TurboTrace ABN system, acid-base neutral for semi-volatiles for 8270 and 625, and that's the focus of our talk today on the sample prep side. And then all of these systems, you can see TurboTrace PFC, that's for PFAS analysis. That is becoming a very big area in North America as well as the rest of the world. All of our automated systems can be manufactured as a PFAS system, and all of our automated sample prep systems automatically deliver the sample into the concentrator for automatic concentration to final volume in a GC vial or LC vial. And then on the bottom, we have the semi-automated systems, which in the last few years, we've taken on the attributes that we could to improve on manual sample prep and added things like separating waste, aqueous and organic, so on and so forth, and your extraction versus conditioning and sample loading using two different manifolds. So you have the easy SPE for drinking water and wastewater, and then the other one is focused strictly on PFAS analysis. So for an overview, we're going to talk about the development of our fully automated system for 8270 and 625. We have a fully validated package that was reviewed by the US EPA, and actually it's on their website for this from the this actual 5-year study that we participated in. It was an ILAI Independent Laboratory Association solid phase demonstration project for method suitability to convert to allow the use of solid phase extraction along with continuous liquid-liquid and liquid-liquid extractions for 8270 and 625 or semi-volatile analysis. We covered a lot of different matrices that are required in order to comply with these methodologies. The study was done with many different independent laboratories using our systems with these wastewater matrices. And then most recently, as I mentioned, we developed these semi-automated systems to handle the analysis or the sample prep for the analysis of 8270 and 625. The matrices that we covered that Rude will speak about a little bit further down in the presentation in a few minutes are DI, tap water, synthetic wastewater, TLC, LP fluid, your surface waters and river and pond, then your influence and effluents from industrial waste coming into municipalities and water treatment facilities, and then just groundwater in general. To compare the two methods, with liquid-liquid, it's a very manual, physical type of methods where there's a lot of setup, lots of solvent, 360 mils of solvent. It's open to background, laboratory background. The people have to actually physically shake the extraction in order to make it happen. So there's no selectivity. There's no. It's just a solvent extraction, and it requires a lot of water removal. So if you put a liter in, you've got to separate that liter from the 360 mils of solvent, and you're going to get a lot of emulsions. With automated SPE and even manual SPE, you're not going to get the emulsions. You're going to have a wide variety of absorbent you can select from. But with the automated piece, you're going to have a closed system. So once you hook up the sample, it's no longer going to be exposed to the outside laboratory and reduce any possibilities of contamination. You have a lot less solvent being used, less than 60 mils basically. It's a filtration process. You're not going to get any, emulsions forming from that. You can do several types of water removal using vacuum nitrogen or sodium sulfate in line. It's fast and completely unattended. With liquid, again, there's no separation of waste. So everything that gets disposed of, water, etc., has been contaminated with some organic waste. You have lots of volume to evaporate, and this is really important, especially if you're trying to comply with EPA emissions issues here in the United States. The minute you automate your extractions over to SPE, you're using 6 times less solvent, therefore reducing your solvent emission from the laboratory. So it's a pretty improvement there. You separate your organic and aqueous waste, so you're disposing and paying for less waste to be hauled away from your facility, and you're going to use less solvent through the process. This is what the Turbo ABN looks like. This is the instrument that for sample prep that Rude is going to be talking about, that will be doing these separations. The cartridges actually kind of what are doing most of the work on this, and we have the ABN to the right here. ABN cartridge, which is a mixed mode cartridge, which is doing the acid base neutral extraction, and then you have the carbon cartridge also to the right. That it's a multi-cartridge system, so it's doing 2 different extractions at one, actually 3 extractions at one time. First, it's going to load the sample across acidified, which Rude will explain. It goes across both cartridges. then you're going to elute with methylene chloride, and then you'll come back and use a basic solution to change the ionic strength, then elute again to get your base off, and then you will elute your carbon cartridge. We use a liquid level sensor, which is there on the left, on the right also, and that's important that we use a vacuum to load dirty samples. So by using a vacuum to load the dirty sample, it's going across one valve before it gets to the cartridge. So very little chances of these systems getting the samples getting clogged. Everybody wants to run dirty samples, and dirty samples can be run on cartridges, and I'll show a couple pictures of that. You have a real-time graphics display. You can run up to 6 solvents. It uses positive pressure to deliver all of the solvent to the rinse bottle and to your cartridge for conditioning and any other washing, etc., that needs to be done. And you can handle a wide range of samples. It's pretty much unlimited. The liquid level sensor will recognize when there's no more solvent sample. Basically, the Turbo ABN fully automates all the processes. There are no manual steps. It's capable of delivering up to 3 fractions, or you can combine them all as one, and do that into the SuperVap concentrator automatically for directed GC vial concentration. It does bottle rinsing, and you can choose either of these cartridges independently, so you can have 2 different cartridge chemistries on at one time, and it's expandable up to 6 modules. This is just a picture to show you of the vacuum and the different sample sizes that you can load using the vacuum, and it's very fast. It's meant to be fast. The sample sizes are unlimited. Is a variety of SPE cartridges that can be used. Any vendors, any size, were capable of using those. Here's an example of some drying cartridges. We tend to use the one on the right, which is more of like a 10 to 12 gram cartridge for drying sodium sulfate. We'll use that in addition to vacuum and nitrogen drying. So you use the vacuum to do the coarse drying of the cartridge, and the nitrogen to do the final step of the drying. So here's a liquid emulsion for those of you who may or may not be familiar with them, but I'm sure you're all familiar with these. And the emulsion encapsulates your analyte, so it's difficult to get the correct result when you have those emulsions forming. So to the left, you have your acid base, you have your acid and base extractions. You can see they're very small compared to your acid and base for the liquid extraction. And again, reduced solvents. These are all, it's a closed system, so you're exposing your sample to much less background from the laboratory. This is just an example of a dirty sample. To the left, you can see it's loaded quite a bit of sediment, so on and so forth, and that is actually being held back by glass wool. The glass wool is in a regular form or stranding, and that helps slow down the particles that would actually block a Brit, which is a punched material filter, and those particulates are going to close that pretty quickly. So next to that, you have the direct to vial concentration. So we've gone and blown down to 1 ml final volume off of the tube from the SuperVap, and we're ready to go to the GC mass spec. So here you can see some examples of the holder in these GC vials. SuperVap comes in many different flavors. This is a 12 position 50 mil vessel, so you can have 6 fractions basically collected, 6 and 6 with this. Again, I talked about this briefly. You can have 2 flavors of it: a 6 position, which holds up to 250 mil, 12 for 50 mil, and a 24 position for 15 mil. It's a dry bath with a heating element in it. It's got a secondary heater which can be disabled or enabled for the extraction nipple. It's sensor controlled, so it's automatically stopping at 1 mil or half a mil, and it has a savable temperature log. So with that, next up is Ruud. Ruud holds a degree in environmental chemistry from the universities of Leiden and Amsterdam in the Netherlands. He previously worked at Rensselaer Polytech Institute in Troy, New York, on the formation of dioxins of PCB and combustion and waste incineration. So with that, Ruud is going to pick up the technical portion.
Yeah, thank you, Tom. So typically we run 1 liter samples, water samples. We acidify them with hydrochloric acid till the pH is about less than 2. And we spike them with the relevant standards. We do cartridge conditioning, dichloromethane, methanol, and water to make sure the polarity of the cartridge is the same as the water samples. Like Tom already said, we have mixed bed for acid, base, and neutral compounds, and we have coconut charcoal cartridges for the remaining compounds. The samples are loaded across the cartridges under vacuum and dried. We do an automated bottle rinse. The rinse bottles are automatically filled every time by the ABN system, and we elute dichloromethane across the mixed bed, and collected will be fraction 1. So the rinse bottles have been filled automatically with the dichloromethane, and then they are blown with nitrogen through the sample jars and then onto the cartridges and collected. After that, we recondition the bed with methanol and then with sodium hydroxide 1% across both cartridges to make the pH high instead of low. And then we collect the other compounds with dichloromethane from both cartridges into one fraction. Fraction 2, we purge the system, we blow it out with nitrogen to collect any remaining analytes, especially the sample lines that are going directly to the collection vials. We blow those out with nitrogen, and then we dry the fractions with sodium sulfate cartridges. We blow it down in, as Tom has already shown, the GC vials to 1 mil, and then we analyzed with GCMS and Joel Farrer from Agilent will talk about it more. Here we have some results. We had different matrices shown here: TCLP, fluid, river water, industrial influent, and wastewater for different compound classes, pHs, phthalates, phenols, ions exchanges, and semi-volatiles. And you can see we're getting very good recoveries between 60 and 110%. Now we'll show some individual recoveries for specific compounds. These are all, I think, about 20 of the most common pHs that were run with the different matrices, recoveries between 60 and about 110%, just like in the other graph, so it looks very good. Then phthalates, 6 different ones also run with these different matrices. Again, recoveries anywhere between 60 and about 110, 115%. Phenols, different types, methylated phenols, chlorophenols, and I think one nitrophenol there. And you see recoveries also between here 40 to about 110% for the different matrices. Ion exchanges here, some anilines, benzene, for the different matrices, anywhere between 40 and 110%. Here are the semi-volatiles that are the bulk of the compounds in these methods, shown here. ethers and benzenes, and some phenyl ethers. So again, for matrices here, and recoveries anywhere between 50 and about 110%. We have, excuse me, done a method detection limit study. Here we have the first, I think, of 4 slides with MDL values anywhere between 0.75 and 2.75 microgram per liter for a wide variety of compounds here, some naphthalines, etc. Here we have phenols and also toluenes and chlorophenols. Again, recoveries between 0.75 and 0.25 micrograms per liter. Some more compounds here. Let's see, some phthalates, I believe, and some PAHs here also. Benzidine, so MDL values between about 0.5 and 4.25 micrograms per liter. Then we go to the last slide, I think, for the MD. Oh, this was already it. So the automated sample prep gives you a really fast work up and concentration time, about totally 80 minutes. And we also have a semi-automated system that follows pretty much the same procedures, and also time-wise, it's just not much different. About 80 minutes. So what we've tried for semi-automation is we took many features from the fully automated FMS systems and implemented them into a semi-automated platform. We developed as many SPE procedures as possible for the testing using a single instruction platform, and we minimized the manual steps to lessen error and maximize limited man hours. So, excuse me, the completely installable these semi-automated systems. We have unpacking videos and installation and training. So no computers or electronics involved. It's just the only mechanical part is a vacuum pump, and it hyphenates the entire SPE process, extraction, bubblage, inline drying, and operation directly into a GC var for concentration. It's the fastest sample processing available for SPE. You can run up to 12 samples simultaneously. The vacuum is used for fast loading of large volume samples, and there is a lot of unattended sample loading and walk away time. And because it's a slow system, you eliminate potential outside contamination. The process is very efficient. It can use all sorts of SPE cartridge sizes. There's a dedicated manifold for loading and drying, and another dedicated manifold for extraction. And there are separate organic and aqueous waste collections. The vacuum can be used for cartridge drying or nitrogen as you want, or combined. There's the automated bottle rinse, just like with the Evolution, just like with the automated systems. Inline extra drying, and there's only a small number of components to clean after every run of 12 samples. And there isn't much capital investment needed, it's low priced. Here we have the EasySPE 12 positions. You can see the blue capped transparent rinse bottles, and at the back you have the glass emmer jar with the green cap that are actually containing the samples. Here we have a layout of the system. We have manifold 1, where the cartridges are conditioned and the sample is loaded. You can see the stopcocks. There it has a vacuum regulator and vacuum gauge. On the side you see the rinse bottles that are grayish and the amber colored sample bottles. There is a base. On the other side you see the collection manifold number 2, which already has the collection tubes in them. Also has a vacuum regulator and a vacuum gauge. So the cartridges are, after the process is on manifold 1, are put on the collection manifold, and then are eluted with the rinses from the rinse bottle. And in the front, you see different valves. We have weight separation, aqueous, and organic. We have stage 1 and 2 vacuum valve next to it. And next to that, to the left, is the nitrogen valve and a nitrogen regulator. And that really pretty much covers it. You see the different valves here again in the front. And I think that covers the semi-automated system here. Pretty much in summary, we have fully automated semi-volatile extractions for various compound classes with excellent recoveries. The method has been validated based on a 5-year US-based study, can be used internationally. Can use many brands of cartridges, and we have excellent MDL results. SVE is a very well accepted technology, and new chemistries and sorbents are being developed every day as we speak. Here we focus on drinking water and wastewater extractions, US EPA method 625, 8270, 608, which is a OCP organochloride pesticide method, and validation packages is available. So capable of inline extracting and drying, and cartridge extract cleanups, and it reduces solvent and use and labor and time. The semi-automated system is easy to use and install, complete water sample prep workflow, low cost, high throughput. So low maintenance solutions, it's very deep green technique. Low solvent use, low disposal cost and emissions, and low electricity use. The semi-automated system and the SuperVap automated evaporation deliver consistent and reproducible results. It handles a wide range of basically any sample size and matrix and any kind of cartridge and column size. It complies with all sorts of existing EPA methods and other methods that regard vacuum and positive pressure and precise delivery of sample and solvents.
Joel is the product manager for the Agilent GC Triple Quad. Joel is a product manager for Agilent for the full Triple Quad GCMS portfolio. He obtained his bachelor's in biomedical science at Texas A&M University, where he gained experience on Agilent LCMS and GCMS instrumentation, performing metabolomics research in the Department of Chemistry. Joel later earned his MBA from the University of Houston with a focus in product management and marketing analytics. And he's been with Agilent in various roles for over 5 years. Thank you, Joel.
Yeah, thank you very much, Tom. Hi, everyone. Thank you very much for having me. My name is Joel Ferrer, and like Tom mentioned earlier, I'm the Triple Quad GCMS Product Manager at Agilent Technologies. I'm really excited to be here with you all and to have the opportunity to talk a little bit more about semi-volatile analysis using Agilent GC Triple Quad with EPA 8270 in mind. So kind of before getting into the meat of the presentation, I did want to take a moment and highlight the latest editions of our triple quadruple GCMS portfolio. So we are recently introduced the 7000E and the 7010C GC triple quads. So these new instruments are the latest addition to the market-leading triple quad instruments and have been built on 5 decades of GCMS excellence at Agilent. The 7000E and 7010C have a new foundation that's kind of designed around mass spec intelligence. So you and your lab can confidently increase instrument uptime and be more confident in your analyses. So the 7000 and 7010 series triple quads do have the same GC compatibility as the previous models. And those are going to include the 8890 GC as well as the Intuvo 9000 GC. And for our new 7000E, we also have a new EI ion source called HydroInert that was built and optimized for use with hydrogen as a carrier gas. So our new GC triple quad instruments are powered by a new, smarter electronics core that enables several new tune, diagnostic, and reporting functionalities. So among these developments is Swarm AutoTune. And so Swarm AutoTune is our new AutoTune algorithm that's based around a technique that you may have heard of called particle swarm optimization. And this is kind of going to use the intelligence of a swarm, right? Like much like a flock of birds or a swarm of insects. And it's going to converge on the best overall tune parameters. So in a traditional method of optimization, simply optimizing one element at a time in a certain sequence, it's pretty simple, whereas tuning a mass spectrometer is a much more complex and multi-dimensional problem, where we know that each component is going to affect the other. So even if the best parameter for the previous element was considered, making an adjustment to the next element may end up actually removing that optimum. And so Swarm is going to utilize the extremely high speed and precision of the GC triple quad hardware to test many parameters simultaneously and then come together to converge on the best overall system settings for the best overall triple quad performance. So on top of the improved auto-tune optimization process, Swarm is also going to enable a twofold reduction in tune completion time. So it's going to average around 5 minutes in an EI mode, which will allow for more productivity on your end. Our new GC triple quads are also host to new diagnostic features, including system screening, system evaluation, as well as a diagnostic tune that function to gather as much information about the triple quad as possible and organize it into a very detailed system report, also called a mass spec report or MSR. And this can be used for quick diagnosis to ensure that your triple quad is up and running when you need it. So the new computing capabilities also enable new acquisition modes like TMRM or triggered MRM and simultaneous dynamic MRM and scan for increased confidence in your compound ID workflows, as well as the ability to perform retrospective analyses without any sample reinjection. And we'll get a little bit more into that mode here in a little while. So as many labs across the world are now and really have been struggling for the past couple of years with the pricing and procurement of helium, Agilent wanted to develop a tool that is able to take away as much of the pain from migrating carrier gas from helium to hydrogen. So this tool, as I referred to it earlier in a couple slides, is HydroInert, and it's compatible with the 7000 series GC triple quad. HydroInert is designed with a proprietary material in an effort to reduce undesirable in-source chemistry, to enhance spectral fidelity, improve peak shape, and result in excellent chromatographic resolution. So additionally, hydrogen carrier gas also enables users to take full advantage of that Van Diemen's curve for faster analysis times, if that's something that they choose to do as well. One of the sort of lesser talked about but very noteworthy advantages of using hydrogen carrier gas with HydroInert is the fact that the same basic principles that our JetClean self-cleaning ion source was built on and makes the HydroInert very similar in that it's very difficult to dirty the source, meaning even less downtime and even higher sample throughput. Finally, there's also the thought of hydrogen safety, right? Many labs are a little bit nervous around having that around, but Agilent has all the tools for maximum safety, including hydrogen leak detectors or the new hydrogen leak sensor module for the 8890 GC, and a third layer of protection as well should you decide to use a hydrogen generator that have many built-in safety features to shut off immediately should any leak be detected. So all of this to provide you and your lab maximum assurance as well as peace of mind. And with that in mind, let's get a little bit more into EPA 8270 for semi-volatiles analysis. So I would go out on a bit of a limb here and make the claim that US EPA method 8270 is one of the most widely practiced methods in the US, if not globally. And it does come with its own challenges. The environmental matrices that are involved are by nature very dirty and require extensive cleanup, like we just saw in the previous presentation. And additionally, the chromatography is complex and requires some particularly challenging separation and resolution requirements for some analytes of interest. However, Agilent has experience, even dating back to the HP days, has the most extensive experience with this method and offers both the equipment and technical support to help your lab achieve its specific goals. So as many of you know, for quite some time, this method used to call for the use of GC single quad. So you might be asking yourself, well, why should I use a GC triple quad, and what extra value does it offer my lab? And there are quite a few. The first benefit is that the increase in sensitivity compared to GC single quad, right? The boost in sensitivity allows for reduced sample sizes with smaller sample extraction volumes, which can save you on the amount of solvent required. MRM mode and DMRM mode enables high selectivity, and as a result, this means faster batch review due to the less complex data. Now, you could be saying to yourself, yes, Joel, specificity can be very helpful, but I can't afford to perform reinjections when I need to reanalyze any sample sets for a compound that really wasn't in my method initially. Well, we have an answer for that. Now we have the opportunity to combine your DMRM analysis with a simultaneous scan to really effectively take the blinders off and have your analysis answer the question of what else is there. The final benefit of following EPA 8270 on a triple quad comes down to the often complicated and timely effort of tune verification. So let's dive into that a little bit more on the next slide. The Agilent triple quadruple GCMS manufacturer's recommended tune has been developed as a communication tool that calls for AutoTune to be used with the reported values from the AutoTune report and check tune. By using the manufacturer's recommended tune for Agilent's triple quadruple GCMS instruments, our customers can increase their overall lab productivity by eliminating the step in the workflow that requires seemingly endless tuning, retuning, and even detuning to meet method performance requirements. The manufacturer's recommended tune applies only to our GC triple quad instruments and includes the 7000C all the way through the 7000E, as well as the 7010A, B, and C. So in my remaining slides, I want to cover some data from 3 different semi-volatile methods that generate excellent results. There's the first one, the standard method with an approximate 20-minute runtime, what we call the fast method with a 10-minute runtime, and the fast hydroinert method that combines the speed of method 2 with our hydroinert source and hydrogen carrier gas. So let's kick this off with our standard 20-minute semi-volatile method. So using the new 7000E that we talked about a little bit before, 74 compounds were analyzed in under 20 minutes, actually 16.9 minutes, using the inert extractor source with a 9mm lens for optimized performance with these tricky semi-volatile compounds. Of those, 71% were able to be quantitated over a standard calibration range of 0.01 micrograms per mil up to 10 micrograms per mil. And of those, over 85% achieved the extended calibration range of 0.005 micrograms per mil up to 10 micrograms per mil. And the data quality is really great as well. In this set, 69 of the 74 analytes were calibrated using an average RF fit with all the relative standard deviation, with a relative standard deviation of less than or equal to 20%. So of these analytes, more than 80% of the compounds had a percent RSC of 10% or less. So certainly, this is in part due to the 9mm lens, which provides outstanding linearity and sensitivity. Early method experiments had used a 25 degrees Celsius oven ramp from 40 degrees to 320 degrees Celsius, but then they modified the oven ramp such that the ramp rate from 260 to 280 was decreased to 5 degrees Celsius per minute. So by optimizing the oven ramp, we were able to achieve improved chromatographic resolution of benzo B and benzo K, shown in figure 2. Now, given that the isomers are considered resolved if the height of the valley between the two isomer peaks is less than 50% of the average of the two peak height, we see that benzo P and benzo K in figure 2 do have that resolution at 88.6% resolution at 2 micrograms per mil. Now, the same with indo 1,2,3-CD pyrene as well as dibenz AH anthracene were also acceptably separated at 62.6% resolution, shown in figure 3. So again, we're getting complete separation of these really challenging analytes. So all that work was completed using the standard DMRM mode. However, I would like to provide an example of how DMRM scan could be used here as well. By simultaneously acquiring DMRM data and an MS1 scan, you retain that excellent specificity of the MRM data, while the scan data allows you to remove the blinders and perform additional library searches as needed. So additionally, the scan data can be analyzed using what many refer to as a hidden gem, Mass Hunter's Unknowns analysis. And in this example, I'm showing a DMRM chromatogram along with a complementary scan tick over 200 pesticides. So then the acquired scan data was run in Mass Hunter Unknowns analysis, and we identified this extremely difficult GCMS pesticide, deltamethrin. Right, that's the power of DMRM scan. So moving into our next method, the fast 10-minute method. Here we have 77 compounds that were analyzed in a wicked fast 10 minutes long analysis using the inert plus extractor source, again with that 9mm lens on a 7000D. And what we see here is that 84% of these semi-volatile compounds were able to be quantitated over the calibration range of 0.02 micrograms per mil all the way up to 160 micrograms per mil. So again, even though we're moving really fast, we still see really great data quality. 90%, which comes out to 68 of these 77 analytes, have passed the average RF percent RSD criteria. And the data showed excellent reproducibility as well, with nearly 80% of these compounds having percent RSDs of less than 15%. Now, there are some things to keep in mind when running this fast method, or really semi-volatiles in general, on a GC triple quad. There are the great benefits, including the 2x time savings from this method, the selectivity benefits of MRM or DMRM, and the faster data review stemming from less complex data. However, with speed, there are some additional considerations. The first is to bear in mind the number of compounds in a method. For best performance, anywhere between 75 to 125 compounds is generally recommended and most ideal. And two, to think about how much sample is being loaded onto the column. Too large of an injection could potentially result in overload and hinder the GC triple quad's performance. So some things to keep in mind there. And as we get into our third method, coming to the hydroinert and hydrogen carrier gas for semi-volatile analysis, and also 10 minutes. So this final method calls again upon our 7000E GC triple quad, but this time the new hydroinert source we talked about earlier with hydrogen carrier gas as well. So this method demonstrates the excellent performance we see on the higher compound end of 120 analytes. 92 of the 120 compounds of interest were able to be quantitated over the standard calibration range of 0.05 micrograms per mil up to 100 micrograms per mil. And of those, over 80% could go as low as 0.02 micrograms per mil. And all 120 compounds passed the EPA method 8270E criteria by at least 7 calibration levels or more. With hydroinert on the 7000E, many of the typical concerns of using hydrogen carrier gas are being abated. Here we see that 104 of our 120 compounds meet the average RF criteria, and over 70% of these have percent RSEs of less than 15%, and all 100 have less than 20% while using hydroinert. Now, just as when we were running fast methods, there are also some pros and cons of hydrogen carrier gas. The huge pro of hydrogen carrier gas is the opportunity to run with hydroinert and all the benefits that that provides. The innate benefits of chromatography on using hydrogen, and the tools that Agilent offers to ensure that your lab is being as safe as possible. Now, keeping the number of compounds in the method is still important, just as it was with helium, but there is something else to consider, the column dimensions. Now, compared to the traditional 20-minute semi-volatile method, which uses a 30-meter by 0.25 column, in order to speed up the analysis, the 20-meter narrow bore column was required, which has a column dimensions of 20 meters by 0.18 film thickness. So here, hydrogen does require some hardware considerations as well. So whether your lab is looking to run the traditional semi-volatile method but on a GC triple quad, increase lab throughput with the 10 minutes method, or migrate to hydrogen from helium carrier gas and use hydroinert, Agilent GC Triple Quad has all the tools to help your lab achieve its goals, from best-in-class specificity to the various GC Triple Quad ion sources and new acquisition modes to remove the blinders to tools to reduce the amount of tuning and get the data that matters most to you. The Agilent 7000E and 7010C have you covered. Folks, I want to thank you so much for your time today. If you're interested, all that I've presented and much more, including application notes and other material, can be found on the 7000E and 7010C product pages and on agilent.com. Thank you very much. And if you have any questions, please feel free to type those out in chat, and I'd be happy to answer those for you.
Great, thanks, Joe. So the chat's open for anybody that would like to ask us questions. Let's see. It says, does your system work for 8081 pesticides in the addition to 8270 SV? And this is from John Giles. Is this for you, Joel, or for us?
I'm not sure. John, are you referring to the triple quad system or for the sample prep?
Our sample prep does 8081 as well. Yes. Yes, John. Ours definitely. We do have application notes on that. You don't need the Turbo Trace ABN system, the acid-base neutral. You can just use the straight Turbo Trace, which is just one cartridge at a time. But yes, we can. And Rude is going to write a note to. We'll send you that application note as well. The system that we didn't talk about it much, but this system also does the 608 EPA 608. It does the extraction, drying, and cleanup all in one step. So basically, you do the extraction portion first on a C18 cartridge, then the extract is automatically delivered to the second cartridge, which is a Hydromatrix and Fluorosil cartridge. So the Hydromatrix is on top of the Fluorosil, and we dry the extract first, and then we go across the Fluorosil, and so the full cleanup is done after the extraction, which is pretty handy. It says, what are the maintenance procedures that are needed, and with what frequency to maintain the sample prep system? So this is from Eric Fawcett. There's a cleaning step that is actually after each run. We have what are called, so the cartridges are removed from the system. We take we put in what are called cartridge bypass fittings. They're lower fittings that attach in where the cartridges go. And we run a sample cleaning program through the system, which goes through the fraction lines, etc. And we actually put the sample lines in DCM basically and load some sample across the system to do that. It's about a 10-minute procedure. Rude, you can correct me or clarify that.
Yeah, that's about
yeah,
right.
it's about a 10-minute procedure. You do have to. We do have folks. You have basic things like lure fittings and fittings do have to be changed, but that's not too often. It could be like a year or more. We have a lot of folks like the people in Massachusetts. Here they have a 6-position system. It's been in service for about 8 years, and they have a service contract. And what they do is every year they'll send a module in, swap out a module, send one in, and we'll do all the lines and check it out to make sure that everything's okay. But it doesn't hurt to change sample lines and the bottle caps with those sample lines. Those are the areas that tend to have the most issues for maintenance. But it's very simple. You can do it yourself. These are not custom bottle cap adapters. You basically can put new fittings right in the existing caps that you have. It says, do you have automated sample prep systems for feed and feed additive systems? And yes, we do. We typically are using pressurized liquid extraction for that. Is that correct, Rude?
Yeah, and column chromatography cleanup. Right?
Yeah,
Power prep.
And then we do the extraction first.
No,
Yes.
that's CE, right?
Yeah, so you do the extraction with the pressurized liquid extraction on feeds and any of those additives, and then we do our power prep or easy prep or any of the column chromatography prep systems that we have specifically for those. And then we have Alina. Hi, Alina. She's asking on the GCMS what extractor lens size do you recommend for using with the 7010B HES source for semi-volatiles analysis, PCBs, and pesticides, Joel? I don't know if you can see that or not.
Yeah, absolutely. And that's a great question, Alina. So what I would say, if you're using the 7010B for semi-volatile analysis, I would operate with just the standard HES source. I would not modify that at all. So just use the regular HES source, and that'll take you, as low as you need to go. But I guess the only comment I would add would be that if you're looking for more like standard ranges, unless you absolutely need that HES sensitivity, I do recommend for this type of analysis using the 7000. But again, depending on what your needs are and what sensitivity you have to meet, it can be done in the 7010 as well. Just have to a little bit more to consider.
Thank you again, everyone, and have a nice day. And we will be we recorded this, so we actually will go ahead and send the recording and information out to you as well. And Joel will send me some information on the instrument also. So thank you again, and we'll talk to you all soon.